On today's episode, new tabletop fusion technology, mobile robotics standardizes, and contact lenses for the ears. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Nuclear fusion has been the holy grail of the power generation industry for decades. Clean, almost limitless power is the promise, but the technology appears to be decades away, decade after decade. Broomfield, Colorado-based Electric Fusion Systems, however, are the latest in a burgeoning small industry of new fusion companies, and they've announced a novel approach to the problem. Co-founders Ken Kopp, a systems engineer, and computer scientist Ryan Wood have announced a new form of fusion physics in a small test device. According to Kopp, fusion reactions in the tabletop experiment have been confirmed by neutron detection, gamma, and optical spectroscopy. The exact physics is patent pending, and the company has not released specific details on their process. They state that it uses something they call cyclical induction, and the fusion occurs in an electrical arc passing through a dense plasma fuel. According to EFS, the process generates electricity directly without the heat conversion to energy through conventional means like turbines. The company also states that their unique fuel creates a very dense plasma, 10 orders of magnitude denser than used in other small-scale fusion technologies. Now, the targets are ambitious, and EFS predicts consumer electricity generated at a cost of 0.8 cents per kilowatt hour. The company's experimental device is notable for its tabletop size and the fact that it operates inside what appears to be standard laboratory glassware, without the heavy-walled vacuum chambers and radiation shielding commonly seen in fusion experimentation. Will it work? With technologies from large tokamaks to mechanical shockwave-induced fusion all ongoing, the EFS technology will be watched with keen interest by players inside and out of the nuclear industry. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Hearing loss due to disease or advancing age is a serious problem for millions worldwide. Now, the miniaturization of semiconductor amplifiers has resulted in hearing aid technology small enough to be carried entirely within the ear, but the amplified sound must still pass down the ear canal to reach the eardrum. Is there a more effective way? A Mannheim, Germany-based startup called Vibrosonic has developed a novel hearing aid design with an integrated speaker that sits directly on the eardrum. The tiny speaker, called a hearing contact lens, outperforms conventional hearing aids by vibrating the eardrum and inner ear bones directly, reducing distortion. The tiny speaker is not implanted but sits on the outside of the eardrum and uses piezoelectric technology instead of a conventional wound speaker coil and membrane. The tiny piezoelectric speaker uses elements as small as 1/1000th the diameter of a human hair and delivers a wide frequency response, 80 Hz to 12 kHz. The combination of direct stimulation and a broad frequency response allows users of the new device to better understand conversation clearly. In its current alpha form, the device is connected to a behind-the-ear power supply and control electronics package, although Vibrosonic expects to miniaturize the entire assembly for completely in-ear use as a next step. The current alpha device is designed for adult patients with mild to moderate hearing impairment. Vibrosonic is a spin-off company of the University of Tübingen's ENT Clinic and the Fraunhofer Institute for Manufacturing, Engineering and Automation. Autonomous mobile robots are in widespread use in large manufacturing facilities and in warehouse distribution centers, automating processes formerly done with human-piloted forklift trucks. The next level of efficiency, however, is to combine the capabilities of pick-and-place robots with the mobility of autonomously guided vehicles. But there's a problem unrelated to the technology: standards. Unless a company adopts a single platform across an entire facility, it's very difficult to get different robots from different manufacturers to work together. Now, that may be changing. Mass Robotics, an influential Boston-based robotics tech hub and startup cluster, has published a consortium-built standard to guide robotic automation interoperability in industry. The standard was developed by a working group formed in 2020 composed of robot vendors, engineers, and end-user companies with the goal of creating a common language which will allow robots from multiple vendors to share status information and rules of the road so they can work together on a crowded warehouse or factory floor. Now, the problem is complex, and the group is focused on which data to collect, the method of sharing it, and the message format. At the current stage of development, the standard strictly applies to robot communication and not task management or safety issues that are already covered by ISO standards. Customer input was provided by FedEx, Procter & Gamble, and DHL. In its current form, messaging is handled by JavaScript object notation over WebSockets, although this may change in the future. Engineers interested in exploring the new standard can consult a read-only script tool on Mass Robotics' GitHub repository. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future not found in our YouTube channel. The links are in the description below. Thanks for watching.